Lesson 3.6, Slope-Intercept Form of Linear Equation. The slope-intercept form of a linear equation is only one of the ways that we can represent the equation of a line. It's in the form y equals mx plus b, where m is the slope and b is the y-intercept. X and y remain variables. The form is useful for graphing and for writing the equation of a line given a graph. And there are three basic forms of linear equation. We have standard form, which is ax plus by equals c. We have slope-intercept form, which is y equals mx plus b. And we have point-slope form, which is y minus y1 is equal to m times x minus x1. And we'll get into these other forms a little bit more later. Okay, so here's an example that we already did using a t-table, and this is where we're going to graph using slope-intercept form. Now, the reason slope-intercept form is nice because if you recall, when we did the t-table, we had to do a lot of calculations to find our 3 points. Sometimes doing a t-table can require many calculations in order to find those even coordinates. By using slope-intercept form, we eliminate the need to do that many calculations. Slope-intercept form is y equals mx plus b, where m is the slope and b is the y-intercept. And this form of the equation tells us our starting point, which is our y-intercept, and then our slope is directions to go from there. So what we want to do is we want to take our equation and transform it into slope-intercept form. So in order to do that, we first move the x to the other side. So we get 3y is equal to negative 4x plus 9. We divide by the coefficient on the y, and we get y is equal to negative 4/3 x plus 3. Now, using our slope to tell us our directions, if our slope is positive, we'll move up and then right. If our slope is negative, we'll move down and then right. The other options, if positive, is to switch both directions and move down and then left, and if negative, to move up and then left. But I find that if you remember that the positive and the negative is the moving up and down, and you always move to the right, it makes it much easier to remember where to go. And this is nice because we don't have to have things that divide evenly, and we don't have to find exact points. So slope-intercept form will work for any equation. You just have to solve for y first. So I make my axes. My y-intercept is 3. So I put a point on 3. Let's label this so we know what we're doing. That's where we start. And then our slope is negative 4/3, which means we're going to go down 4 and then right 3. So I go down 1, 2, 3, 4, and to the right 1, 2, 3, and I put my next dot. So again, we went down 4 and to the right 3. Once I have those 2 dots, I connect them, and I have the graph of my equation. Okay, this was the second example we had done using a table, and again, we had to do a lot of thinking to find whole numbers, and sometimes that's not always the easiest thing to do. So we can convert this into slope-intercept form as well. We subtract 2x from both sides, and so we get negative 7y is equal to negative 2x plus 6. We divide everything by negative 7, and we'll get y is equal to negative 2, positive. Negative over negative gives me a positive. 2/7 minus 6/7. Now you might think, well, now I have this fraction that I have to graph. Well, actually I'm going to show you how using slope-intercept form makes graphing the fractions easier. Now our slope is 2/7, so that means we're going to go up 2 and then over 7. Our y-intercept is negative 6/7. So what I'm going to do is, instead of making each of my lines on the coordinate plane equal to 1, I'm going to label them and I'm going to change the scale. So here are my x and y axes, and instead of this being 1, I'm going to make this 1/7. So that will make this negative 1/7. Then, to find my y-intercept of negative 6/7, I say, okay, negative 1/7, negative 2/7, 3/7, 4/7, 5/7, 6/7. Now our slope is the number of spaces that we need to move. So I don't have to move 2/7 of a space. I move 2 and then 7. And I have my 2 points, and I connect them with a line. So when using slope-intercept form, even if you get a fractional intercept, you just make your scale 1 of whatever the denominator is. So if you had fifths, you'd make this 1/5. If you had thirds, you'd make this 1/3, and then you count the number until you hit your numerator. Now that we know how to graph a line, we can write the equation of a line if we're given the slope and the y-intercept. So we will write the equation of the line with the following sets of information. Okay, remember that the format is y equals mx plus b, and m is our slope, and b is our y-intercept. So when we're given the slope and the y-intercept, all we need to do is plug those in. Slope goes where m was, and the y-intercept goes for b. So here we have a slope of negative 3x and a y-intercept of 3. So I'm going to pause the video now, and I would like you to try the next 2 problems, and then you can unpause the video and compare your answers and see how you've done. Okay, check your answers and see if you got the same ones that I did, and if not, see if you can find your mistakes. Sometimes we aren't given direct information. We're given a picture and we need to write the equation of the line given that picture. So we'll be given a graph. So here we're given 2 graphs, and as we know, we're writing the equation in slope-intercept form, so y equals mx plus b. So we need to find m, we need to find m, and we need to find b. Now b is the y-intercept, and that's where I always start. And so we find the place where the graph crosses the y-axis. So for this one, b is 4, and for this one, b is 0. Then we move along the graph until we find another perfect point, and the perfect point are the points that go right through the crosshatches. And then we count how many spaces up or down, and then to the right. Up will be a positive slope, down will be a negative slope, as long as we always go to the right. So I go down 1, 2, 3. So I went down 3, and then over 1, 2. So that makes my slope negative 3 over 2. So the equation of this line is y equals negative 3 halves x plus 4. On this graph, we could go either direction, but Again, it's always good to go to the right. Here's our next perfect point. I'll go down 1, 2, 3, 4, 5. So I went down 5 and over 1, 2, 3. So that makes my slope negative 5 over 3. So my equation is y is equal to negative 5/3 x plus 0. And since we don't really get anything from adding the 0, we can just call this y equals negative 5/3 x. Okay, for our next set of graphs, here's B. This time I'm going to go up. So I go up 1, 2, 3, and over 1, which makes my slope 3 over 1, which is just 3. So I will get y is equal to 3x plus 2. Here I have b is 3. And in this case, when I go up and to the right, I'm not hitting a perfect point, so I'm actually going to have to go down and to the left. Because I'm going to the left instead of to the right, up would be negative and down will be positive. So I'm going to go 1, 2, 3, 4, 5, because my next perfect point is here. So I've gone down 5, and then back 1, 2, 3. And since down is negative and back is negative, this is going to give me a negative over negative, which is a positive. So I'll have positive 5/3. So I get y is equal to 5/3 x plus 3. Why don't you go ahead? Oh, let me explain number 5 and then you can try number 6. Number 5 is a horizontal line. And anytime we get a horizontal line, we have a slope of 0. So all we need is our y-intercept, which is here at negative 1, and we would have y is equal to 0x minus 1. Well, 0 times x cancels out, so we get y is equal to negative 1. Anytime we have a horizontal line, we just find the y-intercept, and the equation is of the form y equals that number. If we have a vertical line, our slope is undefined, and our equation will be x is equal to the number where it crosses, so in this case, x equals 4. Now, why don't you pause the video and try number 6 and see if you can get the equation of this line. Okay, check your answer. Did you find that the y-intercept was 2, and then that from there you went up 1 and over 2, giving you a slope of 1/2? Here are 2 more to try, so why don't you go ahead and pause the video and try these and see how you do. Okay, check your answers, and if you did not get these same answers, see if you can find your error. Okay, sometimes we have to find x and y intercepts. Now we've already discussed the y-intercept. The x-intercept is where the line crosses the x-axis. And we already know that the y-intercept is where the line crosses the y-axis. So we're going to find the x and y-intercepts of the following equations. Now, finding the x and y intercepts is a matter of, if we want to know the x-intercept, we plug in 0 for y. So to find x, y will have to equal 0. And then to find y, x has to equal 0. So in this instance, when we're trying to find our x-intercept, we do 4x plus 5 times 0 is equal to 40. So 4x is equal to 40, because the zeros make that go away. So x would be 10. This is our x-intercept. To find our y-intercept, we plug in 0 for x, which gives us that 5y is equal to 40, which gives us that y is equal to 8. So our x-intercept is 10, and our y-intercept is 8. When we're in slope-intercept form, we already know our y-intercept. We can still solve for our x-intercept. So I plug in 0 for y, add 12 to both sides. So I get 2x is equal to 12, which gives me that x is equal to 6. So my x-intercept is 6, and my y-intercept is negative 12. In this format, we do the same as we did in example 1. To find my x-intercept, I will plug in 0 for y. So I will have negative 1/2 x is equal to 9. I will multiply both sides by negative 2. That'll clear out the 1/2 and the negative, and I get that x is equal to negative 18. To solve for the y-intercept, I plug in 0 for x. That gives me 3y is equal to 9, so y is equal to 3. So my x-intercept is negative 18, and my y-intercept is 3.